Kirchhoff's current law, KCL. Current flow in circuits is produced when charge carriers travel through conductors. Current is defined as the rate at which this charge is carried through the circuit. A fundamental concept in physics is that charge will always be conserved. In the context of circuits, this means that, since current is the rate of flow of charge, the current flowing into a point must be the same as current flowing out of that point. Three wires connected at a node with different currents traveling down each wire. Kirchhoff's current law states that for the diagram, the currents in the three wires must be related by I1 plus I2 equals I3. It is important to note what is meant by the signs of the current in the diagram. A positive current means that the currents are flowing in the directions indicated on the diagram. The standard way of displaying Kirchhoff's current law is by having all currents either flowing towards or away from the node, as shown on the diagram. Here, at least one of the currents will have to be negative, away from the node and in the opposite direction to the arrows on this diagram, and Kirchhoff's current law can be written as I1 plus I2 plus I3 equals 0. This can be generalized to the case with n wires where all wires are connected at a same node by writing a sum from k to n divided by k equals 0. Exercise 1. Here we have a simple circuit diagram. We can see a voltage source V1, two switches S1 and S2, and two resistors R1 and R2. Positive terminal of voltage source is connected to both switches. On another side, switches are connected to resistors R1 and R2. Then both resistors are connected to negative terminal of voltage source V1. In every path we have connected ammeters for measuring a currents in a path. As we see, we have here two nodes N1 and N2. When both switches S1 and S2 are open, we don't have any flowing current in a circuit. All ammeters show 0 value. Now, if we close switch S1, we can see a current flow I1 through a switch S1 and resistor R1. According to Ohm's law, a current value is 1 ampere. Now we check currents in the nodes. At node N1 we have I equals 1, I1 equals 1, and I2 equals 0. So I equals I1 plus I2. 1 equals 1 plus 0. Or I plus I1 plus I2 equals 0. 1 plus minus 1 plus 0 equals 0. At node N2 situation looks exactly same. Next we open switch S1 and close switch S2. In a closed patch with switch S2 we have current I2 with value 1 ampere. At node N1 we have I equals 1, I1 equals 0, and I2 equals 1. So I equals I1 plus I2. 1 equals 0 plus 1, or I plus I1 plus I2 equals 0. 1 plus 0 plus minus 1 equals 0. Same as at node N2. We see Kirchhoff's current law works perfectly. Now we will close both switches. We achieve a new values of currents. I equals 2 amperes. And I1 and I2 have value 1 ampere. If we check situation in the nodes we have, so I equals I1 plus I2. 2 equals 1 plus 1. Or I plus I1 plus I2 equals 0. 1 plus minus 1 plus minus 1 equals 0. Exactly same as at node N2. As we see, Kirchhoff's current law works perfectly again. Watch on a simulation how Kirchhoff's current law works in a circuit.
Young English engineer. Your way to the electronics world. Like our Facebook page and learn more. Project provided by Tesla Institute. School of Electrical Engineering and Automation.